Alrighty, here are the last few multiple choice problems, 63 through the end of the packet. So here you're given g prime, and you're asked what is following about g. So they're asking you about the function given the derivative. So the first one is g is continuous. Well, this must be true because we are looking at the derivative, and a function must be continuous to be differentiable. So if it has a derivative, it was differentiable, and therefore it was continuous. Same thing goes for differentiable. The derivative exists, therefore g is differentiable. Now here, the derivative at a is greater than 0. That means the function had to have been increasing, so E is the right answer. 64. This is a function f prime. Again, we're dealing with some questions about the function f. Now, f is continuous at x equals a. We have no idea whether f is continuous. We know f is not differentiable at x equals a, but we don't know if it's continuous. So we're not sure if this is false or not. F of a equals 0. Again, we have no idea what f of a is from this graph. So it could be true, could be false. So we can't say a is false, we can't say b is false. I'm going to skip down to D. We very well could have a jump discontinuity at A, but again, we don't know whether we had a cusp or a discontinuity that caused this issue with the derivative. And then once again, for the removable discontinuity, we have no idea if that's what caused the derivative to be like this. The one that we know is false is C, because if f had a vertical asymptote, its derivative would have gone up to infinity, down to negative infinity, up to infinity, something like that. You would have seen some asymptotic behavior also on the derivative. So we know that there was no derivative, there was no vertical asymptote at A. 65. This is the function f. And let's see, the function f whose graph is shown has f prime equals 0. So where is f prime equals 0? F prime will be 0 where the function has a horizontal tangent line. So that is only at 2. 66. Ooh, the derivative from a table. They want us to evaluate, or estimate, f prime of 1.5. So you're going to straddle 1.5 and use these 2 points. So we'll do our change in y values divided by our change in x values. So we have 8 over 0.2, which is 40. So the answer is D. 67. Water is poured into a conical reservoir at a constant rate. Water is entering at a constant rate, but the question is what's happening with the rate of change of the height of the water. Because this area of the surface of the water is increasing, we are definitely not constant in our depth of the water changing. So what's happening is, if you can see this, with the radius being super small, the depth is going to go up really fast. And then as this radius increases, or this area of the surface of the water increases, the rate at which the depth is changing is actually decreasing. So it's going to be nonlinear, first of all. The rate at which the change in the depth of the water is happening is going to be nonlinear and decreasing because the water level goes up very quickly at first and then it levels off to go up more slowly. So the rate is very high and then goes lower. The rate of change of the depth of the water is very high at first and goes lower. So nonlinear and decreasing. Okay, last 2 problems. We are looking at a graph of f, which is 2 line segments and a semicircle. F prime equals 0 for x equals what? F prime equals 0 only where the function has a horizontal tangent line. So that is going to be only at 4. Now, where does the derivative not exist? That is going to be wherever the function is not differentiable. So at these 2 cusps, and also at this endpoint, which looks to have a vertical tangent line. So I would say 1, 2, and 6. The other option would be to say 1 and 2, because sometimes we don't discuss 6 as it's an endpoint. So I'm not sure what the answer key calls for. If they're just looking at an open interval, then go with 1 and 2. If they're looking at a closed interval, which would be rare to ask about differentiability at an endpoint, then you would also count it non-differentiable at 6.